In this video, we're going to talk about using logistic regression and in particular using solver uh, as the add-in that would be able to do logistic regression for you in Excel. The point on logistic regression is that it's very much like linear regression. The only difference is the outcome is either a yes or a no type decision. So let's take, for example, here a situation where we're trying to determine whether a person gets a mortgage. Okay, so it's either yes, they get the mortgage or they don't get the mortgage. Two variables that go into this is the percentage of down payment and the income to loan ratio of the person that's putting in for it. Again, looks very much like a linear regression where you have y, the outcome. Did they receive the mortgage or not? It's going to be, the computer's going to give you an intercept. It's going to give you betas for each one of the two coefficients, either the down payment or the income. So what we're going to do in Solver, what you can see here is we have a list of somewhere around 30 or so people who have either been approved for a loan, for a mortgage, or not approved. We have their percentage down payment and we have the income. So we're going to go up to Classify, and in Classify we're going to choose Logistic Regression. Choose your range, highlight what you're looking at. Once we've put that in here, the first row has datas. Just taking a second to see what's going on. Whenever yours first comes up, it probably will look like this. It will have all your variables here. We know that being approved is the outcome variable that we're looking for, so I click on it and bring it over. We also know that the two selected variables that I'm interested in is the down payment and the income to loan ratio. Two classes, it either is approved or not approved. Everything looks good here. We'll go to Next. Make sure that you have variance covariance matrix selected and analysis of coefficients. All right, we want a summary report and we can finish. This is what the outcome or the output looks like. It says that using this approach, we can explain 46.8% of the variance and whether or not someone is going to be approved or not based on our two variables. Okay, so again, R squared 46.8%. The coefficients, two ways to look at the coefficients here. From a statistical standpoint, what we're looking for is the p-values. Okay, remember that p-value of less than 0.05 means that the significance not due to chance is less than 5%. So you can see our p-values here are all less than 0.05. So it makes sense that all of these variables stay in our model. And then once we've come through, the last thing that we have is the actual coefficients themselves. Intercept is minus 9.3671. The beta coefficient for the down payment is 0.1349. The income 0.1782. Okay, so we're going to go back over to our example. And you can see once again what I just got was from Solver, we get y equals minus 9.367 plus the beta value for the down payment plus the beta value times the income. One thing that we can do once we develop a model like this in logistic regression, very similar to linear regression, we can calculate the outcome variable, okay, whether or not someone is going to get a loan based on the equation that we have. However, since this is logistic regression, and the reason we call it logistic regression is because it's based on a log system, if we want to calculate the probability of someone getting a loan, then we have to use this equation, where the probability is the intercept with an exponent, okay, again, logistic. So we're going to do, since it's a log base, we're going to take the exponent of it, and over here it's similarly. All right, so what we are doing in this situation is, what's the probability that a person with 20% down and 30% income will get approved. So we know our beta, 0.1349. The beta value that we have is 20%. The next one, the beta coefficient for number 2 is 0.1349. Beta 2, for which is the income, is 30% income to loan. So I'm going to click on this so that you can see the way that the equation comes out. It's this equation here with everything in it, all right? The intercept, beta 1 that we got from our model, times the 20, which is given to us because we're trying to, once again, we're trying to predict what the chance is that, or the probability that someone will get a mortgage with 20% down and 30% income to loan ratio. All right, so our 0.1349 times 20, our 0.172 times 30. And again, because of the log function here, this goes in the denominator just like our equation says. What this does for me though, is now I have a model. I can tell someone that walks through the door that has 20% down and a 30% income to loan ratio that they have a 21% chance of being approved for this mortgage. Again, should we use the model? That's the question that's going to come up. So back to our outcome. What we have in this logistic regression is we get a confusion matrix, or which we could take and turn into an error report. So using our data, once we went through and we used those two variables, it says that in the case where the person did not get a mortgage, all right, there were 13 times that people did not get a mortgage in that. Using this current model with the data that we have, going back through and looking at the data that we used to train our model, of the 13 that didn't get one, our model would have gotten 11 of those correct. Okay, again, they didn't get the mortgage. Our model predicted they wouldn't get a mortgage. However, our model missed it twice, okay? Because twice, even though our model would have predicted that they wouldn't get the mortgage, they did get it. Secondly, let's look at one where the mortgage, they did get it in our data set. That's a total of 17. Our model with this data predicts it correctly 15 times, but using this model, once again, we would have predicted that they would have gotten the mortgage, and in fact, they didn't. So we can take these numbers and develop what they call a percent error, okay? So again, here we got 11 of them correct, 11 out of 13. So again, error report, 13 of them. 2 of them we got wrong. 2 divided by 13 is 15.4%. Look at the ones, 17. 2 times, we didn't get it correct. 2 divided by 17 is 11.8% error. And our overall for all of this was we got it right 30 times, we got it wrong 4 times. So the percent error on this is 13.3%, or our model predicts things correctly 86.7% of the time just using the 2 variables. All right, hopefully this makes sense to you and gives you an idea how to use logistic regression, how to calculate the probability, and then also how to use this confusion matrix to determine whether or not we should keep this model.